Hi guys, today I'm just gonna talk about the what I learned today. Today the main topic is the B tree. Okay, to understand like the yesterday I just talked about the what is B tree and the how B trees come from. To summarize it, the B tree is just kind of like the limitation of normal tree data structure that when there are some kind of index file, rather than putting into one all records key into into just the one array, we're trying to figure out which is the best data structure because the when you're trying to put all of the records keys on the array, that means that you have to traverse more orbits. So we just trying to think about the best way because we are software engineers, and the limitation of tree data structure is there is not necessary example. The normal binary tree data structure can have only one node, and if the depth is increased, the more time complexity increases. So that's kind of the limitation of the binary tree. So that's why B trees come from. So I'm just gonna try to explain you the B tree. So B tree is just kind of like it has characteristic of the binary tree, but it's kind of really like it's really amazing, but it's kind of hard. Let's say well, let's say you have let's just randomize. You have this kind of input, and you want to make a binary tree. The binary tree, the B tree. First, there's a of course the root of it. You put 34 on the root, and you put 28 in the root. Of course, you have to decide the max size of the minimum degree of it. Example, if minimum degree is 3, the max key is, I think it was like 2, yeah. T minus 1 is like so max key is gonna be 2. And so let's do it. Wait, is this right? Wait, hold on. Get the formula. The max number of the keys. Yeah, 2t minus 1 is gonna be 2t minus 1 is gonna be 2t minus 1. 2t. If I put 3 on it, I have to put 2 on it here. Yeah. Sorry, I have to put 2 on here, and the 2 times 2 minus 1 equals to 3. So our max key is gonna be 3. The length is gonna be 3. And let's begin. And now you insert 28. And now you have to insert the 40. But the thing is that the binary tree has the nodes has to be short. So it's gonna be this 34 is gonna be shorted by this part. And I think this is gonna be really important thing. Those kind of like little box on it. Those kind of box, this mechanism will help you to understand how B tree is gonna be worked. And you insert the 40. But however, you already learned that the max keys, the length is the 3. But we have 3 keys, so we have to split into it. But how do we split it? We just define our keys length into 3, because even though we put 10 or whatever, we eventually have the 3 or 5 or 9 or whatever. I don't know how to say, but it's not divide. It cannot really divide it into 2 value. So we can just use this formula to it. T minus 1 is equal to primary key index. So our T minus 1 is actually 1. So this is 0 and this is 1. And 34 is gonna be our primary key. And based on this, we separate 28, 40, and 34. And you go up And the 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 character of the binary tree is binary tree is the left part is go to the value that is smaller than the root value, or right part go to the right part is for the value that is bigger than the root. So that's gonna be like this, and it's very simple. Now you have 30. Rather than you put into the root of it, you put the left on it. I mean, because the 30 is smaller than 34. So after you go to 30, and now you insert the 50, and you, of course, you're gonna go here, and 26 is gonna go here. But now we already made the maximum case. These 28, 26, 28, 30 is already maximum. And now we just did what we're gonna select the primary key, and we're just gonna put this 28 into parent node of it. And 28 goes to this part of it. And the pointers is gonna remain like this. And now it's very simple. Now you put 39 on here, and after you put 39, we compare this stuff. And after you put the 39 on this node, but you realize that this is also limited. I mean, it already exceeds the maximum, the key length of it. So you find the primary key value, and you go to the parent node. You merge into parent node, and the value and the pointer is gonna be like this. Pointer is gonna be like this. Yeah, so this is pretty simple. So we now just have beautiful node, but also we just created already maximum node, and we just put this 34 key onto the top of it. So this kind of beauty, and 29 goes gonna be here. It's gonna be go here. Yep, 29 here. Like this. So this kind of beauty of the B tree. If it's normal binary tree, the depth is gonna be more increased because the node only have the one key. So the binary tree is gonna be more deep since the limitation of the size of the node. But B tree it isn't. So if you look at here, it's gonna be more simple, and you'll be able to find the target index or target key compared to the B tree, binary tree. So this is how you remake it. You have this. I'm trying to implement, but I was not able to make it really perfect. But you have to find the lift node, and after if you find the lift node, and if there's no children, you have to go just put the value into node of it. So that's very simple. So I think this is it. So see you next time, and yeah, see you next time. Yeah, sorry.